with the type of lettuce we're growing in this project, two assumptions can be made. The first being that 70% of seedlings successfully germinate, and the second being that there's a 64-week growth period. With these two assumptions, we have two different options for plant growth. The first being germinating the seedlings in their own germination chamber and then moving the ones that grow into the growth chamber. And the second would be to plant the seedlings into the growth chamber and let them go from seedling to maturity and then harvest. Both of these options have comparable yields, but we decided to choose option 2 because there's less waste with not having to over germinate the plants. So as you can see on this graph here, both option 1 and option 2 have very similar yields throughout the whole growth cycle, but option 2 has a little better yield and it has less waste, so it's the option we decided to go with for this project. So with this updated option 2, the only reason we need to move the plants would be for full growth or if there's a death in the plant. So if there's death in the plant, the robotic arm will come through and remove the dead plant and plant a new seedling into that growth chamber, or at full growth it will remove the plant from the chamber to allow harvesting by a human. So in order to move the robotic arm, we've have a proposed motor and a proposed motor driver to handle this. The motor is a 6-wire stepper motor that has a step angle of 1.8 degrees, meaning 200 steps per cycle, with a torque of 90 Newton centimeters. These cost around $50, and depending on what we use them for, we could need up to 6 motors. And then the stepper motor carrier operates from 8 volts to 35 volts and can deliver about 1 amp per phase.